mechanism refers to the process that is designed to detect, prevent, or recover from a security attack. Security service means a processing or communication service that enhances the security of the data processing systems and information transfers of an organization. The services are intended to counter security attacks. Security mechanism is the basis for a security service that is designed to detect, prevent, or recover from a security attack. Example mechanisms are cryptographic algorithms, digital signatures, and authentication protocols. Security mechanisms, they are technical tools and techniques that are used to implement the security services. The common security mechanisms are access control lists, in short they are known as ACLs, cryptography, digital signature, secure socket layer SSL, and finally firewalls. We'll see one after the other. Access control lists. In network security terminology, ACL is a table used to filter the network traffic by controlling whether packets are forwarded or blocked at network boundary based on the criteria specified within the access list. Each network interface has a specified attribute that identifies its access control list. The list has an entry for each interface that specifies what kind of network traffic to be passed. ACLs may be configured in routers or switches based on the need. Second one is cryptography. It is the process of transforming a readable message, which is called as plain text, into an unreadable message, which is known as ciphertext. And then it transforms the messages back to its original form. The first one is known as encryption. The second one is known as decryption. Of course, this terminology has been derived from two words, crypto and graphy. Crypto means secret, graphy means writing. So, cryptography means the art of secret writing. This actually occurs as follows. The sender converts the plain text message into ciphertext, which is known as encryption. The ciphertext is being transmitted to the receiver through the communication channel or the transmission medium or the communication system. The receiver converts the ciphertext message back to its plain text form. This is known as decryption. Cryptographic systems are classified into three independent dimensions. First one, the type of operations used for transforming the plain text into a ciphertext. Substitution. This is the first method used. Here, each element in the plain text is mapped into another element. Second one, known as transposition. Here, the elements in the plain text are rearranged. The second one is the number of keys used. There are two types. One is a symmetric crypto system and the other one is asymmetric crypto system. In the symmetric key or secret key encryption, single key is used by the sender and the receiver. In the asymmetric key or public key encryption, the sender and the receiver, they use different keys. The third one used is the way in which the plain text is processed. There are two methods here. First one is known as the block cipher. It processes the block of elements at a time. The second one is known as stream cipher. That means it processes the input elements continuously. The third important security mechanism is digital signatures. A digital signature is a technique that generates a digital code that is to be attached along with the message which is being transmitted over the internet. It makes use of the public key cryptography to validate the authenticity and integrity of the message, software, or a digital document. Digital signature ensures authentication, non-repudiation, and integrity of the message. Let's see the digital signature computing process. First of all, during the exchange of electronic messages, the sender or the key supplier shares the public key with the communicating users. Message digest is a small piece of information created using a hash function on the message, and then message digest is encrypted using the private key of the sender to form the digital signature. Hash function is used to maintain the integrity of the message. Since the value of the hash function, it's a mathematical element, is unique, any changes in the message will result in a different value. In the third step, digital signature is transmitted along with the message. Fourth, receiver decrypts the digital signature using the public key of the sender and computes the message digest from the same message. Fifth phase, the receiver verifies the signature to ensure the authenticity of the message. If the decrypted hash matches the received computed hash of the same data, it proves that the data has not changed during transit since it was signed. If the two hashes don't match, there is a possibility that the data has been tampered. The next one is the Secured Socket Layer, SSL. SSL protocol was developed by Netscape, and it provides a secured connection between the client and the server of the network applications over the internet. SSL runs above the transport layer and below the application layer. SSL is a point-to-point security mechanism used to provide authentication, message integrity, and confidentiality. SSL makes use of the combination of public key and symmetric key encryption system to secure the connection between two machines. SSL contains 4 sub-protocols. They are the record protocol, change cipher, spec protocol, alert protocol, and handshake protocol. Record protocol. This builds the data path between the sender and the receiver and provide confidentiality using conventional encryption and message integrity using a message authentication code. In short, it is known as MAC. Change cipher spec protocol. This indicates that the communication is shifted from unencrypted form to encrypted form. Alert protocol. This sends errors, problems, or warnings about the connection between the communicating parties. Fourth one, handshake protocol, defines how a client and server establish a SSL connection. The fifth and foremost important security mechanism is firewalls. A firewall is a combination of hardware and software that's used to maintain security of a private network. It applies the security policies at the boundary level between two or more networks. There are certain design goals a firewall should satisfy. They are: all traffic from inside to outside the network must pass through the firewall. Only authorized traffic will be allowed to pass from a firewall. Of course, firewall has certain characteristics. They are service control, direction control, user control, and behavior control. Service control. It determines the type of internet services that can be accessed by the network user. The inbound and outbound traffic may be filtered based on the IP address and TCP port number. It can be implemented by proxy software or host on the server software. Direction control. It determines the direction such as the inbound and outbound in which particular service requests are allowed to flow through the firewall. User control. It controls access to the service according to the user. Each user will have ACL indicating their level of access. Based on ACL, the user traffic may be allowed or denied. This feature is typically applied to users inside a private network to control the outbound traffic. It may also be applied to incoming traffic from an external user, but it needs proper authentication technique. The last one is known as behavior control. It makes use of statistical data to control the traffic. Controls based on how particular services are used. For example, filter email to eliminate the spam or avoid spams. Or it may also enable external access to only the portion of the information or on a local web server. Of course, firewalls are of different types. There are 3 types which are commonly used. They are packet filtering, application gateway, and circuit level gateway. Packet filtering firewalls filter each packet that attempts to enter or leave a private network. It will either accept or reject them depending on the predefined set of filter rules, which is based on pattern matching. Application gateway. It's a firewall proxy filters the inbound traffic to certain specific applications such as Telnet, FTP, file transfer protocol servers, real-time streaming protocol, and BitTorrent. Circuit level gateway provides TCP and UDP connection security, and it works at session layer of the OSI model. It monitors the TCP packets, handshaking between packets to ensure that the session is a legitimate one, and fulfillment of firewall rules and policies. Finally, there is another mechanism called notarization. Notarization means selecting a third trusted party to control the communication between the two entities. The receiver can involve a trusted third party to store the sender's request in order to prevent the sender from later denying that the sender had made a request. Dear learners, different security models follow different approaches, and the selection of the suitable one depends on the organization's need and applications. Different security models are briefed here in this chapter, and the standard ISO 27001 model with different security mechanisms are deliberated. Thank you. We will meet again in the second phase of week 5.